out of your window, okay, what do you see? You see the buildings, you see the roads, you see the MRT. All these are the work of engineers. Now look inside your room. You have your mobile phone, you have your laptop, right? And then you have the internet. And these are the things that are absolutely essential in our lives today. And again, engineers have contributed significantly to the development of such technologies. And of course, looking in the next 10 years, you can see that many jobs in Singapore especially, require engineers. For example, in the agri-food sector, okay, many engineers will be required, okay, especially with expertise in process control, automation, and robotics. And as we all know, we're all pushing for electric vehicles on the road. Okay, not only electric vehicles on the road. In NTU, I can share with you that there's a group of engineers and professors who are building Singapore's first flying electric car. Okay? So to put all this in place, you need the infrastructure. You need maintenance. You need people to look out for the safety. And again, engineers are the people who will be doing such things. So looking at the jobs of the future, okay, what is important? To me, I think sustainability is key, looking at what we require for the future jobs. This is especially so for a country with no natural resources, like Singapore. Okay, we have to ensure that whatever we do, it needs to be sustainable. Okay, we have to ensure that we have a place for our grandchildren and our grandchildren's children to always call home in the future. So the government has laid out the Singapore Green Plan 2030 with very, very ambitious goals. Let me share with you a few of them. Okay. In 2030, we want 80% of all buildings in Singapore to be green. We want to reduce power consumption by 8 million megawatt hours per year. And we want to reduce our domestic greenhouse gas emission by 3 million tons per year by 2030. 2030, it's just 9 more years to go. To achieve this, engineers will have to play a part. And not only engineers have to work alongside the other professionals. Just in the news this week, in fact, just 2 days ago, Straits Times reported that NTU engineers are looking at the feasibility of using the Sembawang hot spring as a source, as a geothermal energy source. Okay? We are also looking at the possibility of storing carbon dioxide underground. Of course, there's this impending worry of sea level rising. Okay? Again, engineers have to think about the greenest method to ensure that Singapore stays high and dry. So, it is clear to say that there's always been a demand for engineers. And this demand would only grow in the future, especially in the next 10, 20 years. Now, let's look at the skills of tomorrow, especially what is required of an engineer tomorrow. World Economic Forum has published this recently. It is the top 10 skills that are required in the industries by 2025. And this is general. I mean, it applies to lawyers, doctors, all right, architects. Let's go through some of them. Okay, the first on the list would be analytical thinking and innovation. Okay, we require employees to be active learners, and we have learning strategies, problem-solving skills, and the list goes on. In fact, all these skills can be generalized into 4 main subgroups: problem-solving, self-management, working with people, and technology use and development. Okay. Let's take the lawyer, for example. All right? Probably it'll tick a few boxes, but maybe we do not require a lawyer to have technology design and programming skills. Okay. But then engineers, I believe personally, that engineers tick all the boxes over here. And we have an urgency to ensure that engineers acquire such skills in the near future. In fact, I feel that the pandemic has shortened this timeline. Okay? The challenges and problems of tomorrow must be solved today. Right? So, coming back to what I said earlier, right? There is this shortage of engineers, this constant shortage of engineers. Why so? Some of you might be thinking, well, maybe because engineers don't remain as engineers for too long. Well, that may be true. Because of the versatility of the engineering training program that we have, engineers are very versatile. Okay? They tend to morph. They tend to go into other industries and other disciplines. Right? You have engineers that after working a few years, they go into business, they go into finance, okay, they start up their own companies, they become entrepreneurs. Some of them go on to join the C-suites of multinational companies. They become the CTO, CFO, and so on. So I think that if you think that this is a leakage problem, I think it's a good problem to have. In fact, it's not a problem. I would say it is encouraged. This also means that the engineering degree is well sought after. Okay? And if we have this constant shortage of engineers, then the solution is really to train more engineers for the industry. So, what is the main difference in the way we train engineers, let's say 10 years ago, and today, and moving forward? I would say that the main difference is that engineers today would require interdisciplinary skills. Let's look at what Lawrence Wong, our education minister, has to say. In the real world, many issues are complex and cut across different disciplines that cannot be solved by an engineer alone or an architect or a scientist. It really needs different skill sets to come together. Right? So interdisciplinary education is key moving forward, not only for engineers, but for many fields. So here I put together 3 main reasons why interdisciplinary skills are required for the engineers. Okay. We are now in the 4th industrial revolution. Okay. Some call it Industry 4.0. Let's take a step back. In the previous industrial revolution, okay, we have the physical world, the machines, the robots, combining with the cyber world, which is the internet, coding algorithms as such. Okay. But with this industrial revolution, we have an additional element put into this mix, and that is the biological system. And when I say biological system, I mean us, people. Okay? We are now put together with the machines in the cyber world as well as the physical world. Now, this complicates matter because human beings, we are highly complex. Okay? We have moods, we have emotions, okay? And the machines would have issues dealing with this. Okay? So by putting the human into the equation, okay, us engineers, we have to design systems and products for the human being. All right? This may seem trivial, but it is not. Let me share with you an example. Before the iPhone came about, okay, in the era of the Nokia phones, okay, all the engineers like myself, we were wondering, when can we have a full internet browser on our smartphone? Okay? And at that time, I was given a sample of a phone, not made by Apple, okay, but it was made locally, okay, and it has a full browser, internet browser on the phone. And I was excited because, wow, this is great. This is what I've always wanted, okay, and I'm glad to see that a local company is looking into it. So I tried the phone, you know, And I found that it has all the features that you require of a browser. Unfortunately, it was very, very difficult to use. There were a lot of buttons, okay, there are a lot of maneuvers that you need to perform before you get into the website that you want on this particular phone. So clearly, that company, although technically sound, they did not look into how user-friendly the device would be. They didn't consult social scientists, they didn't consult ergonomic experts, and things like that. And unfortunately, that company and its product did not take off. And then soon after, we have the iPhone, okay, the very first version of it. It was simple. It was user-friendly. It has only one button. Of course, the latest iPhones, there are no buttons, right? So it's very, very important that we work with other people from different disciplines in order to get the solution correct. The second point here is we have to look beyond book knowledge. Of course, being an undergrad, you would have to rely on books for knowledge. But in the real world, okay, it's more important to have skills, acquire skills, doing the job, on-the-job training, and really actually doing the work that you have to do. And that is extremely important. Let me give you an example, okay? As an electrical engineering undergraduate, obviously you will have to study Kirchhoff's law, okay? But studying and practicing Kirchhoff's law on paper is very different from actually applying Kirchhoff's law in a real electrical system. In the real world, you will be actually applying Kirchhoff's law, and that comes with responsibilities. Okay, if anything goes wrong, then it is the engineer's responsibility to rectify it. And let's say this same electrical engineering undergraduate moves on to work in a data center. And as you know, in a data center, there's a lot of circuitry, electrical circuitry, which of course create heat. Okay, and if there's heat, you need to dissipate it. Okay, and if you require heat transfer systems put in place, then you need to understand the second law of thermodynamics. Okay. Then the question is, would you expect this electrical engineer to go study thermodynamics to understand that part? No. He has to learn to work with the mechanical engineer, who is an expert in heat transfer and know all the laws on thermodynamics. But this electrical engineer has to understand that heat is a problem. So he has to understand a little bit more beyond what his discipline has taught him. And similarly, the mechanical engineer must understand how the circuitries work in order to do their job better. And finally, moving forward, there has to be a holistic approach to problem solving. Okay, gone are the days, okay, where we just look at the technology, and if the technology works, it has to be good. Okay? We have to work with the other disciplines to understand the finances. Okay? We still have engineers that do not think about resources. They think that resources are infinite and they can build the best possible device. But if the device is so expensive that only 10 people in the world can afford it, then it is not a product. So we have to be holistic on the effects and the impact these new services and products would have on the world, in the financial world, the aesthetics of it, and moving forward, very importantly, how would this affect the climate? How would it affect the environment? So let's look at the traits of tomorrow's engineers. Okay, Singapore is going from a knowledge base to a digital economy. Okay, and in this digital economy, STEM education is imperative for the nation's growth and sustainability. Okay, we have no choice. Okay, this is the only way to go. Okay, a good reason would be our total fertility rate. It is going down. Okay, Singapore, as we know, we are always top 10 in many, many things that we do. The best airports, the best ports and such. Unfortunately, in terms of reproducing ourselves, okay, we are one of the lowest in the world. So moving forward, okay, if we don't have enough people to replace ourselves, we have to rely on science and technology, okay, to do the work so that the country would continue to progress. So how do we do this? How do we move from a knowledge base to a digital economy? Okay, first of all, we have to train our employees to be T-shaped, especially the engineers. What do I mean by T-shaped? Okay, if you stretch out your arms like that, okay, your height, that is the depth. All right? If you are going to be trained as a biomedical engineer, then you jolly well have to study biomedical, bioengineering, deeply, and to understand all the principles and skill sets that are required of a biomedical engineer. But at the same time, we need to be a little bit broader, okay? And this is to do with how interdisciplinarity would be more and more important moving forward. All of us, especially engineers, need to know a little bit more about the other disciplines, okay? Finance, sales, marketing, the arts, okay? We want engineers to go deep into the discipline, okay? Be very sound engineers. At the same time, enjoy the arts, appreciate the arts, for example, okay? Play a musical instrument, recite Shakespeare, for example. And then the other thing that we require is leadership. Okay, even in engineering, okay, developing leadership skill sets is very, very important for the volatile and uncertain world that we live in. Okay, and leadership is required for groups of people, interdisciplinary groups of people to work together, okay, for a common goal. Now, let me give you a few examples on why interdisciplinarity is very important. Okay, here you have a medical robot, and that is my field of research. I built surgical robots to help surgeons in their work. Okay, so being a roboticist, obviously my team, my students, we are sound in the engineering principles of robotics. Okay, so you can see here that we go deep into robotics, the design, the coding, and stuff like that. Okay? But as we go on the journey of actually building a robot that is going to be used clinically by the surgeons and the medical doctors, we find that, oh wow, their input is just as important as the engineers, or even more important. Right? So there are feedback that are totally new to us. Okay? From an engineering point, for example, in order to cut a tumor, for example, a cancer tumor, we'll just find the best trajectory and things like that. But from a medical point of view, it is not so. Okay? There are certain protocols to follow that we cannot change for medical reasons that us engineers, we don't know. Okay? And then it's also very important to look at ergonomics. Okay? Even though we think that this is a very good device and it can help the patients, but if the surgeon is not comfortable using such a device, then it's not going to work as well. Okay? And then we have to look at health economics. Again, citing the example that I gave earlier on. Okay? If the robotic system is going to be so expensive that very, very few hospitals can afford it, okay, then it's not going to make sense economically as well. It's going to be too expensive to be purchased by the hospitals. At the same time, it's going to be too expensive for patients to afford. Okay? So from the start, we have to look at all these different areas, and we have to work with very, very different people to ensure that at the end of the day, we come up with a system that is feasible, that has benefits, and it's economically viable. Okay, another example is smart gadgets. Okay, smartphones that you have in your pockets today. All right, so as you can see, just talking about engineering itself, all right? It basically takes a village of engineers of very, very different background to come together to put together a product like this, all right? Besides the microcomputer that you have, okay, you have sensors, all right? Sensors that sense your phone, your biodata, your fingerprints, the latest sensors, very, very accurate micro pressure sensors that will be put into phones, okay, that will enable the phone to tell you, not only the location, through GPS, but it can tell you which floor are you in a building. So these are the intricacy that will be put into the phone, and bioengineers are responsible for such things. Of course, you have the smart display, and that's the material engineers coming into play, and most of it, cybersecurity and all the apps that you have, computer scientists and computer engineers would contribute a lot into it. Okay, the electrical and electronic engineers, 5G, people are already talking about 6G and so on. Okay, and at the end of the day, all right, behind this, beyond all these engineering marvels and engineering contributions, all right, there is the human aspects as well. Okay, all the apps are connected to us humans, and why we, being humans, would feel comfortable using such applications. Now, let's talk about the changes that we're putting in place, at least in NTU. Okay? And what I'm going to share with you is not the perfect solution. All right? In today's world, I would say that change is the only constant. Okay? What's important is that we have to be dynamic in our approach. Okay? And we have to prepare future students for the VUCA world ahead. Okay? As I said many times, the emphasis is on interdisciplinary skills, along with disciplinary and domain expertise. Okay? So you can see here that these are the requirements that we have put in place in NTU for a student to obtain a bachelor degree in engineering. Okay? You would require about 135 to 137 AUs. Okay? So the major changes that you see here as compared to, let's say, 5 years ago is that now 63% would be catered for major requirements. We're talking about core and major prescribed electives. Okay? As I said, we need to be T-shaped engineers, okay? And this is the depth. This is your height. Okay? If you are a mechanical engineer, then this 63%, you'll be studying design, you'll be studying thermodynamics, okay? And all the things that make you a mechanical engineer. And there's no discount on that, right? But what's interesting is now there's a growing proportion of broadening, okay? This year alone, we've introduced, for the very first time, and I think that this is the first in a university in Singapore, we have introduced what we call the interdisciplinary collaborative core. At 32 academic units, it makes up about 24% of the requirement for AUs. Okay, what do we study in this 24%? Okay, there are the common core, okay, which can be broken into the key transferable skills, okay, like communication in the interdisciplinary world, navigating the digital world. It's important to understand ethics and civics in a multicultural world, and entrepreneurship. And there's also an emphasis on addressing grand challenges that we face, every one of us in this world. We're talking about science and technology for humanity, sustainability, okay, in terms of society, economy, and environment, and of course, healthy living and well-being. Okay, so in this common core, what's interesting is, for the very first time, okay, in the same classroom, you will not only have engineering students. Okay? In the same classroom, we would have the business students, okay, the humanities students, the social science students, okay, the science students, and sometimes we even invite the medical students into the same classrooms. Okay? So from day one, you can see we are designing that even as freshmen, you get used to being in an interdisciplinary environment, working with people outside of your discipline. Okay? And as you do your freshman year, doing this Common Core, there will be projects. And I assure you, in every project that we have, the students will be put into group with different, with students of different disciplines. Okay, so you can imagine, let's say the project is to, well, for example, let's build a automated wheelchair, a robotic wheelchair that will move automatically to its destinations, So you will have the engineers, okay? You have the business people, you have the social scientists, for example, in a group. The engineers, of course, they'll go on the way to design, to build the wheelchair, to look at the navigation systems, okay, the coding and stuff. Okay, the business students will look at the business plan, to write out a business plan to see how you can market and sell this wheelchair for real. Okay? And of course, the social scientists, they have to understand the patient that has to use this wheelchair. How would this patient react to this new invention? Okay? Would there be something that the patient would not be comfortable with? Okay? And all this has to be studied. So such would be an example of interdisciplinary projects in the Common Core. And then we have the foundational core. Okay, and this is just for the engineers, all kinds of engineers. Okay, be it the mechanical, the electrical, civil engineer. Okay, in today's world and for the jobs of tomorrow, okay, it is absolutely important that every engineer understands data science and artificial intelligence. So this is given to them, okay, from day one as freshmen. Okay. There's also engineering communication, all right, which is very important. And of course, we put in professional internship for the engineers as well. The last 13% you see there is really broadening and deepening electives, and that is the breadth. Okay. Remember the T shape. Okay. This is our arms outstretched, and this is where the student from all disciplines can basically choose any subject that is outside the scope of his or her discipline, okay, and they are totally encouraged to do so. Okay, so you can have an engineering students taking a humanities subject, for example, in social science, humanities and social science college. All right, what else are we doing here at NTU? We have the work-study degree program. And I must say I'm very, very excited about this. Okay? We have to come back to what we're trying to achieve here. Okay? The 4 years that you spend in the university as an engineering undergraduate is, well, one of the main reasons is to prepare yourselves for a job outside. Okay? And with this work-study program, it's going to be a win-win situation because as you study, you are already in the workplace. Okay? In fact, in this program, you are expected to have 4 stints in the companies. Okay? 4 internship stints in the company. And as we all agree, okay, the best way to learn is really to be working in a company. Okay? And I myself, when I was doing my engineering undergraduate in NTU in the 1990s, I remember. Okay, at that time, we only had one opportunity for internship. It was a 6-month attachment to a company. And during that 6 months, I learned so much. I remember that at that time, it was year 3, and we've just been taught computer-aided design, CAD drawings. And of course, we've done it in the school laboratory, but it's just on paper. It's just in the computer, and we don't actually go on to build the stuff, right? But in that 6 months, I was given an opportunity to not only design, but actually to build those things that I've designed. And of course, theoretical and practical is totally different. From there, I could understand that there were so many considerations. There were so many mistakes that I made. But again, after 6 months, I became a lot more proficient. Okay, I remember I came back to NTU and I was also teaching my instructors all the shortcuts that AutoCAD offered at that time, that only a practicing engineer would know. We are also offering a minor in design and systems thinking. Okay, this is a good continuation of the interdisciplinary collaborative core, the ICC that I talked about. Okay, so in the first year, in the freshman year, students of all disciplines will go through ICC. But as they go on to the second year, or the third year, they could take this minor in design and system thinking. Okay, this is where students as well as instructors from different disciplines come together, and to teach design and system thinking. Okay, that's the main objective of the course. But to do this well, you have to understand the other important aspects of system design thinking. We have to be holistic in our thinking. Okay, there will be introduction to psychology. Okay, why is psychology important? Okay, well, psychology, with a knowledge of psychology, you will understand what product would work and what product would not for a human being. Okay, we would also study marketing communications. Okay, product design, and to sum it up, there will be an interdisciplinary project work. Again, the students will be grouped with people from other disciplines. Okay. We also feel that it's very important to develop skill sets through holistic education. Okay. So what I've mentioned so far, they're all the formal education that we have put in place in NTU. Okay. But as engineering students, we give you the space and the time to stretch your arms and your legs, okay, to explore for yourself, okay, in a university setting, how it is in the real world. Okay, so we totally encourage you to join the student clubs, for example. Okay, and there's a whole variety of student clubs in your schools and outside your schools that you can join. And this is where you can use the engineering skills that you have acquired for good, with possible impact to the society. Okay, we have clubs here that send students during their vacation period to nearby countries to build schools in the rural areas. Okay, other clubs send more technical ones. They send their students to rural villages and see how they can get, for example, fresh water channeled into that village. Okay, so these are real applications that students can participate. And well, you can imagine the satisfaction level is very, very high. Okay, we have maker spaces all over the campus in NTU. Okay, it is very important for students to explore innovation and enterprise and entrepreneurship. Okay, and engineers by nature, we are all builders. We are makers of things. Okay, so maker spaces. We equip them with the latest 3D printers. Okay, there's facilities to build your electrical circuits, software, and whatever you want. Okay, to try it out, to build your prototypes that you want. Okay, one of the maker spaces is sponsored by Dyson, and again, there's opportunity to learn from the very best in the industry. And talking about industry, okay, NTU we are really, really good in collaborating with the industries. Okay, in fact, in terms of collaboration with top MNCs, okay, local and international, okay, we're probably doing very, very well. So any point of time, if you walk around NTU, you will bump into a HP engineer, Rolls-Royce engineer, okay, Alibaba AI scientist, okay, or an on-campus. Okay, obviously, we have very large research collaborations where it's led by the professors and the PhD students and the researchers. But we want the undergraduates to join in as well, to be exposed, okay, to the cutting-edge technologies that we have, the products of the future. And that is very, very important for the education for the engineers. Okay. Entrepreneurship, again, as of this year, we have rolled out the very first second major in entrepreneurship. Okay? We feel that engineers are wealth creators. Okay? And again, going through this course, it doesn't mean that you have to be an entrepreneur. But more importantly, you have to instill in yourself, in every one of us, okay, the entrepreneurial mindset. Okay? We need to be able to push ourselves out of our comfort zone, okay, to look at the possibility of doing something different, okay, to take calculated risk, okay, and, to accept failure. Nothing is for sure, right? So in this second major in entrepreneurship, you'll be exposed to formal education, okay, how to write a business plan, for example, how to pitch to investors, looking at finances and things like that, okay? And you'll be sent for a stint in a startup company for your internship, okay? And finally, on top of all this, we believe that it's very important to nurture great leaders. Okay, so in NTU we have leadership programs, okay, formal ones that students can take, okay, to improve their leadership skills. We have a student ambassador program as well. Okay, this is where students are given an opportunity to lead projects and activities. Okay, they have to look into resource management, okay, and do a little bit of strategic thinking, okay, in order to complete the project. And mentorship, that is very, very important. I myself, as the Dean of the College of Engineering, I have a mentor. Okay, all my professors have mentors too. Okay, the senior professors will be mentoring the junior professors. And students, you being the most junior in the university, you are in the most privileged position. Okay, you have mentors from everywhere. Okay, you have the professors that will be mentoring you. You have the senior students who would be mentoring you, and you have the alumni who would come back to mentor you as well. Okay, so these are some of the activities that we have put in place in order to nurture great leaders for engineering in the future. This is my last slide. So in conclusion, I would say that tomorrow's world is highly volatile, uncertain, and complex, and even ambiguous. Right? So the engineers of the future is required to have technical knowledge that go far beyond a single domain to address the challenges and the problems of tomorrow, which, I remind you, must be solved today. Okay? A curriculum that is interdisciplinary and robust is required so that engineers can be adaptable to the ever-changing and dynamic demands of the labor market. Okay, and finally, engineering students need to go beyond just academic knowledge. All right, skills are important. They need to equip themselves with skills that will enhance their effectiveness in contributing to the engineering professor. In fact, it's important to get skills as you go along the way. Okay, go beyond book knowledge. Okay, it's more important to know where and when to require the appropriate skills. Okay. In conclusion, I want to compare what we are going to roll out to nurture the engineers for the future now and during my time when I was an engineering undergraduate in the early 1990s. Okay, that's 25, 30 years ago. Okay, at that time, in the School of Mechanical and Aerospace Engineering, okay, 4 years, okay, we were given robust training in mechanical engineering, which I'm totally appreciative of. But it was just mechanical engineering. During that 4 years, there was very, very little breadth. Okay? I only mixed with other mechanical engineering students. I didn't even mix with the electrical or the civil engineers. Okay? And don't talk about mixing beyond engineering with the business students. Right? But nonetheless, most of us turn out well. most of us turn out to be very sound engineers. Okay. Now, moving forward is all about interdisciplinarity. Okay. You're given so many options, okay, to improve on your breadth, okay, but still maintain that depth in your discipline. Okay. At the same time, okay, with what I've shared with you, you are in a position to actually carve out the persona that you want to be, the kind of engineer that you want to be. For example, okay, if you are very motivated to be an entrepreneur in the future, then you can start choosing subjects and courses, okay, like the major in entrepreneurship, so that you are steered in that direction. Okay? Some of you might know that's not my cup of tea. You want to be, more of a scientist, and come back to academia and research. Again, you can steer your courses in that direction as you go through the 4 years. So if you ask me, given an opportunity, which route would I go? I can tell you that if I am to relive my undergraduate days all over again, I would definitely choose to do it now, okay? Given the options and what we're trying to achieve here. It is simply just so exciting. Okay, so with that, I'd like to end my lecture. Thank you.
Thank you so much for your very nice talk, Luis.
Thank you.
And we have now come to the Q&A session. If I can encourage all the participants, if you have any questions, please post it at the Q&A chat box right below your screen. I have one or two questions to begin with, Professor Fee. One of the questions being posed is that to educate future engineers in Singapore, faculty will also play an important role in mentoring students and instilling this new mindset that you talk about. In your views, how shall faculty members at College of Engineering prepare ourselves for this new paradigm?
Right. So I think that faculty, we need to walk the talk. Okay? It's no point telling the students, hey, you need to get out of your comfort zone. You need to work with people from the other disciplines. Okay? Interdisciplinarity is so important. But faculty themselves, they stay within, their domain. Okay? So even as we speak, I'm encouraging faculty to go beyond what they know. Okay? To reach out and work with other faculty from other disciplines or even the industry, okay, to come together to teach the students. I'll give an example, all right? The keyword today, the buzzword is artificial intelligence. So you can imagine a professor in a computer science, teaching artificial intelligence. Obviously, he has to go through all the technicality, the coding, okay, the algorithm, okay, machine learning and things like that, all right? But if he's not able to, to give the students a good perspective of how artificial intelligence is going to impact the society or the world, then I'm afraid he's not going to do a good job. So what he needs to do, for example, is to reach out to a humanities scientist, okay, or social scientist, another professor in the College of Humanities and Social Sciences, okay? And for that social scientist to, to help educate on how AI can be used to impact the society. For example, in this pandemic that we are experiencing now, okay, AI can be used to predict how the diseases are going to be spread. It's going to spread, right? Using AI, it's not going to be very accurate if you do not understand human behavior, right? So if the social scientists can come in to work with the AI scientists on human behavior, then obviously the algorithm would get a little bit more accurate. Okay, so that's just an example.
And I guess in ICC, when we build the curriculum, the faculty across different colleges will have to come together to build the curriculum, isn't it?
Of course, yeah. So, there won't be any boundaries
Yes.
between schools and colleges moving forward. Okay, we need to break down all the walls and ensure that not only faculty but students go across to work with other disciplines.
Okay, good. Right, I've got another one. You're a strong proponent of innovation and entrepreneurship. And innovation is abstract to many students, right? How do you think innovation can be taught effectively in the education ecosystem?
Right. So I feel strongly that entrepreneurship is something that all of us need to embark on. Again, I stress, not every one of us would become an entrepreneur. Okay, but it's important for every one of us, okay, all the students from any discipline, to have an entrepreneurial mindset. Okay, so take the second major in entrepreneurship that we have just wrote out. Okay, certain things can be taught. Okay, as I mentioned during my lecture, how to write a business plan, looking at finances, how to pitch to investors, these things can be taught. Okay? But the gumption of being an entrepreneur, okay, the tenacity, this cannot be taught. Okay? This has to be grown and inculcated through a culture. So in NTU, what we're trying to do is to build a culture of entrepreneurship and enterprise within the university. We want that buzz, that electricity in the air, right? We want students to, very, very organically come together to talk about new ideas, crazy ideas that would, probably fail, okay, so to speak. But that's not the point, okay? The point is to get people excited about new ideas, to try it. And we want to have a culture that is also more forgiving, that we encourage people to try, but if it fails, then we have to celebrate that failures and learn from that failure as well. Okay, so that's our approach for entrepreneurship in NTU.
Okay, great. On a related point, I have this comment and a question as well. This comment goes like that. Let me just scroll to the right one. Skipped. Okay, right. So thanks, Prof. Lewis, for the exciting outlook to make NTU education system relevant to the ever-changing world. And the question is whether can we create more opportunities for students to venture out in our region. So we are talking about regional now, and extend the opportunities for Singapore.
Yes. So as it stands, we have 70%, okay, this is again pre-pandemic, right? 70% of our students spend time overseas, okay? Some months, it can be an internship, it can be an exchange program. In fact, ND, we are going to push it to 80%?
Yes, indeed.
Right,
yes.
okay.
Yep.
So we're pushing even more students to really get out there.
Yes.
Of course, they go all over the world, okay? But, looking at where the growth is, moving forward, it's all in Asia, specifically in ASEAN countries, okay? So we want our students to, to really spend time in ASEAN countries, okay? So again, of course, we have a lot of exchange programs, okay? I'm involved in a dean's network, right? And all the deans are from colleges of engineering within ASEAN, okay? And we exchange a lot of ideas, okay? And during our meetings, we sometimes bring the students along with us to interact with students in ASEAN countries. So I think that such activities would only grow, okay? And we want more collaboration with universities from ASEAN countries, okay? And we want our students to really get out there, to spend time there, to understand their goals and their challenges, and for their students from ASEAN countries to come to Singapore as well, okay? I'm very excited about this growth that we will experience in this region. And the only way to take advantage of the situation is for ASEAN countries, neighboring countries, to get together and work as one.
Okay, that's good. Right, so I'm going to ask you a high-level question. From a resource point of view, it takes time to establish the support and pillars necessary for interdisciplinary education. What can schools and institutions do to facilitate this process?
Right. I think we've started on the right foot, okay, with the Interdisciplinary Collaborative Core, the ICC, okay, where we get all the freshmen from all disciplines to come together. Okay, that itself, well, I can share with you, it took the university almost 2 years of planning, okay, and a lot of resources put into it. Okay, that is a great start, I would say. Okay, that would get people from year one, okay, when the rubber hits the road, okay, to get comfortable talking and working with other students from other disciplines. And the hope is that with that first year, learning as an interdisciplinary group, okay, that organically, as the student progresses into the second, third, and final year, okay, the student can reach out by him or herself to other disciplines and get students from other colleges and schools to work with them. Okay, along the way, we have, for example, the minor in system design, okay? That would, again, require students from different disciplines to work together. But all this would probably culminate in the final year project that all final year students have to go through, right? Up to now, I would say that most engineering FYPs are still done as solo projects. I feel strongly that this has to change. Okay, I look forward to the day and in the near future that all FYPs are mandatory to be group projects. Okay, but of course, to do this, then we have to ensure that we change the assessment rubrics. Okay, to ensure that it is going to be a fair system, that you'll be given the grades for the part that you are in charge of. Okay, but again, very, very importantly, we have to ensure that people from different disciplines work together throughout their undergraduate studies so that when they go into the workforce, they would start working very effectively from day one. Because the truth is, in the real world, no engineer just works within his or her domain, or no business graduate would just look at the business part. There's a lot of crossing over and interaction with other disciplines. So, well, you jolly well get used to it in the university.
And in a safe environment, like the university, right?
Yes.
Yes. Okay.
Certainly.
Mm-hmm. Let me see. Okay. All right. I have the next question. Next to introducing broadening subjects to engineering degrees, do you think this will mean that the content of the more traditional engineering subjects or courses will also need to have a revision?
Well, yes and no, I would say. Mm-hmm. Okay. I mean, engineering, it depends, right? If you're talking about mechanical engineering, the laws of thermodynamics hasn't changed for the longest time, and I don't think it will change, right? Yeah, so, certain core courses, okay, that is important for that particular discipline has to be taught, okay? And it's not going to change. I mean, the principles wouldn't change, but okay, the method of teaching could change, okay? So, I mean, even as we speak, okay, professors are using AR and VR, virtual reality, augmented reality, okay, to teach the same old principles, but in a more user-friendly manner. Something that would, well, definitely excite the students, but also get the students more involved. Okay, for example, forces. Right? Remember this? I think we all learned this, right? Yeah. So, it's a three-dimensional problem, right? Forces, right? 6 degrees of freedom and as such, right? Which can be quite difficult to visualize on a two-dimensional screen, right? But putting on, using augmented or virtual reality goggles, okay, you can see this in 3D. I guess a student would automatically appreciate and grasp the subject a little bit better, right? So those are for the more traditional courses that need to be taught, okay? But for, courses like artificial intelligence, blockchain, okay, machine languages, there's just so much changes and at a speed that is quite unimaginable. Okay, so the way of teaching would have to change as well. Okay, I mean, like I say over and over again, no point teaching someone things that they can already find out from the internet. Okay, there has to be experience, okay, put into it, stories and real examples that you can only get in a good university setting. Yeah, so we are exploring those methods as well.
Yeah. Indeed, technology has really changed the way we teach, the pedagogical aspects of teaching. Yeah. We have a question from a budding engineer. He mentions, I'm interested in defense engineering. What advice can you give regarding the course I choose and the paths I can take?
I see. Well, defense is big. Okay, it's all important for the nation, right? So we are working very well with the defense-related science and technology like DSO, DSTA, as such, right? So we have links with them, okay? And there are projects that we do with them as well that we always involve even undergraduates, right? So there's no shortcut. Okay, you have to come in as an engineering undergraduate. You go through the foundational courses, okay? But in your more senior years, maybe your second and third year, okay, there would be opportunities to work with professors, okay, on defense-related projects, okay? Get yourself, linked to the defense science and technology. And as we progress, there will be more exposure for you. And as I mentioned, all right, internship is very important. Okay, we can certainly get you an internship in MINDEF, for example. Okay, and hopefully you would graduate. Okay, and you could become a defense scientist or an engineer. Okay, and there's a large percentage of students who are actually interested in defense science and technology that go on to do their further studies in NTU. So it's a true train to the master's or the PhD before actually going to work in the defense industry.
Right, okay. In your lecture, you share about industries working very, very closely with NTU in terms of educating the next generation and preparing them for the next generation. So we were just wondering, what are the roles of industry in the education ecosystem? How can they better work with schools and universities to prepare their future workforce?
I see. Well, that's a very good question, actually. I said during the lecture, right? 4 years that you spend here, okay, as a student, one of the main reasons is to prepare yourself for the job that you are going into when you graduate, right? So it is very important that the linkage between university and the industry is as close as possible, okay? At least this I can say. NTU is doing a great job in our collaborations with the big boys, Alibaba, Hewlett-Packard, Rolls-Royce, okay? So the good thing is, because of this collaboration, students are exposed to the cutting edge technology that even the companies are looking at. Okay, so that's one good thing. But I think that they can play a bigger role in the formal education of our students. Okay, so moving ahead, we're going to explore getting professionals from the industry to come to NTU to be part-time teachers. Okay, and this is very important because for the many years that I've been an academic, I always hear companies complaining, hey, what were you teaching in the university? When they come here, they don't know this, they don't know that, and we have to retrain them all over again. Okay, so by getting, the professionals, the practicing engineers and professionals to come to the university to do some teaching, okay, this would be their chance to instill in the students what they want of their future employees. Okay, so that's one thing that certainly we can step up on. Okay, on the other thing, right? You're talking about our professors and lecturers, right? It's important for them, again, not just to be more interdisciplinary. Okay, it's also very important to ensure that they do not lose touch with the real world. Okay, so I'm encouraging my professors to take time off to do their sabbatical, not in the usual, university somewhere in the world. Okay, but also to consider a sabbatical with the industry, okay, to be put into a real company. Of course, the professor would be contributing in terms of research, but also to be exposed to, things that the engineering professor would not be exposed from a day-to-day basis. For example, sales marketing, interacting with the customers directly. And this, again, will give the educator, the professors, a better perspective of what the challenges are in the real world. And, with that, I'm sure they'll do a better job in educating the students.
Which is why doing engineering education these days is much better than when we used to do it.
Yes, amen to that.
Okay, I have another question. How would you advise employers in the region that engineers' remuneration could be made more competitive compared to other professions?
Well, I'm also an entrepreneur. Okay, I started companies. Okay, and I understand how it works out there. All right, I think it's we stop sulking or complaining that the salary is not high enough. Because in the real world, it's all about demand and supply. Okay, rather I think it's more important to revamp the brand of engineering. Okay, the prestige of being an engineer. Okay. Onus is on us to get out there to show people and to tell people how valuable we are in our contributions to the industry and the society. Okay? And it's for us to get out there to prove to people that, what we learn, the skill sets that we have, we are very versatile, okay? And we can contribute in many, many areas. Okay? It's very easy for the engineers, as I mentioned earlier, to morph himself into some other disciplines or professions. Okay? But it's not easy for other professions to morph him or herself to become an engineer. Would you agree?
Yes, indeed.
Yeah. Yeah. So that is a very valuable skill set already. Even as I speak, our students, and I think it's a good thing, graduating from engineering, their first job is not in engineering. Okay? They get snapped up by the banks. Okay, with very high-paying salaries, right? Students from computer science and engineering is very hot now. Okay, they have very, very competitive starting salaries as well. Okay, so I think the onus is really on us to get out there. Okay, to be entrepreneurial. Okay, to be more business savvy, to know more than just engineering, and to market ourselves. And with that, the salary and the increment will come naturally.
Mm-hmm. That's good. Yeah. One last question before we end today's session. From a student's perspective, what can they do to instill and inculcate interdisciplinary education?
Okay, so, well, at least we have laid the foundation.
Yes.
Okay, with the ICC, well, to put it bluntly, the students have no choice, okay, but to get together to work with students of other disciplines, you know, to work on projects, yeah. But I think students, they need to know what's coming, okay? We've always been talking about the VUCA world, ambiguous, you know, you don't know what to expect. And the good thing is, you know, information is available to everyone. Okay, so students should go out there to find out for yourselves what is required. Okay, as a freshman here, you know, 4 years in the university it's not a very long time. Okay, it will just zip by before you know it. Okay, and then you graduate and you get out there. Okay, rather than wait for the final year after your final paper and your FYP to think about, you know, the job and how you want to contribute. Okay. I think students should start this thinking from day one. Okay, as a freshman, how you want to contribute to society, to the industry, and ask yourself, rather than us, you know, the educators telling you that interdisciplinarity is important, you find out for yourselves. You know, search the internet. What's going on? You know, why politics is linked to the industry, you know, why engineering is now linked to humanities. Find out for yourself, okay? And I'm sure, you know, you will find out that the world of tomorrow is very, very different from the world of just 5-10 years ago. And with that in mind, you know, hopefully, organically, you would bring yourself to understand why interdisciplinarity is important.
Mm-hmm. Any final words to our employers, organizations, educators, as well as students?
Well, engineering is one of the oldest professions in the world, right? It goes back a long way, and it's well sought after, okay? And going forward, we are going to evolve. We're still going to be engineers, okay? But it's exciting to know that with what we are trying to achieve here, we'll be churning out engineers that are going to be different and are future ready, okay? Engineers that would not only be interdisciplinary, okay, but engineers who would care for the environment, okay, would always have sustainability as he or she does his work, okay? And it's going to be exciting times ahead, and we want to work with everyone, okay, future employers, okay, students, to ensure that we get this correct, so that at the end of the day, okay, the nation, okay, the society would prosper from everyone's contribution. Thank you.
Okay, thank you so much. With that, we have come to a close for this Tuan Centennial Fellowship lecture. We would like to take this opportunity to thank the crew behind the scene, the people who have worked on the talk, the slides, as well as, of course, Tuan Foundation. Thank you so much for your time. Have a good rest of the week.